Hi guys, welcome to our virtual lab. Today is going to be a little bit funny, so just try your absolute hardest. I completely understand if this is a little confusing. It's different than what we would do if we were in person. However, we're going to try our absolute best. Okay, so basically we're doing a birth and death token model. Births and deaths are always happening in a population. How does the number of births and deaths in a population affect its size? Does it get larger? Does it get smaller? Does it depend on how many births versus how many deaths? To find out, we're going to try these missions below. I want you guys to start off by checking out the posted Google Doc on Google Classroom. So you should open up this Google document. It looks like this. It's attached to your Google Classroom. Once you have, we're going to follow these steps along together. I want you to add think about 14 tokens in this circle on the token model population. Okay, so think about a population of, let's say, we're working with meerkats today. So each of these little green tokens represents a meerkat. Every year, 1, 2, or 3 organisms are going to die, and 1, 2, or 3 organisms are going to be born. How much is up to me? To make an organism die, we would just simply remove it from the circle. To make an organism be born, we would add a token to the circle. We're going to repeat this until we've modeled 6 years of this meerkat population's lives. At the end of every year, we're going to record the number of deaths, births, and organisms on this chart here. Okay, so the number of births, deaths, and organisms. I want you guys to keep track as we go. So you should be watching the video and typing in the number of organisms that we've got as you go. At the end of the 6 years, you're going to add up the total number of births and deaths and record it in the total column. Once we've completed this, we're going to answer a couple of questions thinking about if our population if our population stays the same, increases, or decreases over time. So our first mission is to make the population size stay the same over time. So let's call it year 1. Everybody's looking in this column. Year 1. We start off with 14 meerkats in our population. I'm going to say that there are 2 births and 1 death this year. I want you guys to record it in the table just like this. So I would record births 2, deaths 1. Organisms left, let's see. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's go to year 2. In year 2, let's say this year we've got just 1 birth, and I'm going to say we have 3 deaths this year. It was a really cold winter. So on my chart, I'm going to type in my number of births was, 1. Our number of deaths was 3. And our organisms left are 4, 8, 12, 13. All right, year 3. I'm not going to type it in the graph, so I want you to follow along and record it yourself now. Okay, so this year, we are going to have 3 births, woohoo, and 3 deaths. How many are left over? Should be the same, about 13. We've got 13, so our population is staying the same. What about if we do for year 4, it's year 4 now, so everybody's looking in this column. Year 4, I'm going to say that there are 2 births and 1 death. How many total are there left over? 4, 8, 12, 13, 14. Back to our starting number. Okay, we're in year 5. In year 5, let's say that there are 2 births and 1 death. How many are left? 4, 8, 12, 13, 14, 15 meerkats left after year 5. Moving into year 6, let's see our total here. Let's have 2 births this year and sadly 3 deaths. We got some grandpa meerkats passing away. Okay, we are left with a total of 4, 8, 12, 13, 14 meerkats. Okay, so on your graph, you're going to type in 14. Now let's think of, over the 6 years, how many total births did we have? So I want you to count across this row here. How many total births did you have? Then how many total deaths? Count across this row here. Type your final answer there. And how many organisms are we left with? How many organisms are we left with? Well, we ended up with 14 organisms, and we started with 14 organisms. So did we complete our mission of making the population size stay the same? Yes, we did. Now we're going to come on down here and say, when the population size stays the same over time, the total number of births blank the total number of deaths. Did you have the same number of births and the same number of deaths here? Was the number of births and deaths less than? Was the number of births less than the number of deaths? Or was the number of births greater than the number of deaths? You should find that it's about equal. So go ahead and check off equals. It should be roughly the same number. Now we're going to do the same thing, but this time we're going to try to make the population size increase over time. Okay, so we're starting off with our 14 meerkats. And this time, since we want to increase our population, I'm going to go ahead and start off with a strong year 1. We're going to have 3 births this time. Go ahead and type in 3 births. And I'm going to say only 1 death this year. Year 2, let's see. Let's give it another 3 births. Lots of happy meerkats, lots of meerkat babies. Okay, and this year we're going to only have 1 death. Okay, what about year 3? Let's give it another 3 births. Oh, we forgot to count how many total. Oops. All right, so if we added 3 minus 1, we actually added 2, so this should be 16, and this should be 18. Okay, so year 3. Now let's see, how many births did we have? We had 3 births, we had 1 death, and we end up with, let's count, 4, 8, 12, 16, 21. 21 total species. Okay, year 4, let's see. We have 3 births and 1 death. So now we should have 4, 8, 12, 16, 23. Okay, year 5, we're going to add 3 more births and 1 death. So we've got 5, 9, 13, 17, 21, 25. Okay, and in the final year that we're tracking, let's say we have 3 more births and 1 death. Oops, sorry. and 1 death. Okay, now we've got 5, 10, 15, 19, 23, 27 total species. Okay, so your chart should look like this. Oops, we only deleted one. Okay, so to effectively make our population size increase over time, how many total births did we have over 6 years? We had 3, 6, 9, 12, 15, 18. How many deaths did we have? We had 6. Okay, so did our number of births end up being greater than our number of deaths? Yes. Down here, we're going to say the number of births is greater than the number of deaths. Okay, we're going to reset back to 14. 4, 8, 12, 14. Okay, and now to do our death. This time I'm not going to track it at all. I want you to track on the graph on your own and do your calculations. Okay, so we're going to have 1 birth the first year and 3 deaths. How many are we left with? 4, 8, 12. Year 2, we have 1 birth, 3 deaths. What are we left with? 4, 8, 10. Now I'm going to say let's have in year 3, 2 births and 3 deaths. We have 4, 8, 9. Year 4, we have 3 births, but we have 3 deaths. What are we left with? 9. Year 5, let's give it 2 births and only 1 death. We had a good year. How many are we left with? 10. And year 6, let's say we have 1 birth but 3 deaths. How many are we left with? 8. Count up your total number of births here, total number of deaths here. Then I want you to think about, in order to make our population size decrease over time, was the number of births greater than, equal to, or less than the number of deaths? Go ahead and check your answer down here. You should have determined that it is less than. Great job.